we're going to take a look at an example that is a little bit more detailed and has a little bit extra work to it, but we'll take a look at another example and how that works. So we say that a manufacturer makes long sleeve and short sleeve t-shirts, and each long sleeve shirt requires 4 minutes on the cutting machine and 3 minutes on the stitching machine. Okay, so 4 minutes to cut and 3 minutes to stitch. Every short sleeve shirt only requires 3 minutes on the cutting machine and 1 minute on the stitching machine. The cutting machine is only available for 2 hours each day, and the stitching machine is only available for 1 hour each day. And we're going to end up organizing this stuff into a chart to represent kind of what it means. So if the profit on a long sleeve shirt is $1.10 and it's 60 cents on a short sleeve, how many of each should be produced each day to maximize profits? Well, what we want to do is we want to try to maximize our profits. And so our target equation is going to be maximizing profit. Well, first things first, before we get to our target equation, let's define our variables. To get our target equation, we need to know how many shirts of each we're going to make. So X is going to be the number of long sleeve shirts made, and Y is going to be the number of short sleeve shirts. There's another extra E in there. Made. Okay, again, making sure that we are defining our variables in a good sense. Our target equation, we're looking for profit. So our profit is going to be 110 multiplied by X plus 0.6 Y, and that's going to give us our profit. So depending on how many long sleeves are made and how many short sleeves are made to maximize the profit. Now, X being, or our long sleeves being more, okay, they're going to give us a higher profit, but they also take longer to make. A couple of the restrictions that we have, we know that they both have to be positive values. So our domain, X, is a part of all whole numbers. We're only having whole numbers here. And our range is going to be Y, is also a part of all whole numbers. All right, now, to figure out what's going to maximize, we're also told that we have a maximum amount of time each day on our cutting machines and stitching machines, and this is we're going to come up with a bit of a little, well, to come up with our inequalities, we're going to make a little chart. Okay, so we're going to make a little chart that's going to figure out our cutting and our stitching, and it's going to compare those two. Okay, so we're just going to make a little chart here. For a long sleeve, we need 4 minutes of cutting, and we need 3 minutes of stitching. Short sleeve, we need 3 minutes of cutting and 1 minute of stitching. It's pretty quick. And total, we have 2 hours here and 1 hour there. Okay, so we can, because we have other things in minutes, let's change this to minutes as well. It's 240 minutes, and this is 120 minutes. All right, now how do we put these into our inequalities? Well, for the cutting, for every long sleeve we have, we're going to need to take up 4 minutes. For every short sleeve, it's going to be 3 minutes, and the maximum amount of time we have is 240. So, oh, sorry, oh my goodness, a little mistake here. That's not 2 hours. That's 4 hours. Let's just quickly change that. 120, and that's 60. There we go. Okay, that's 60 minutes, and that's 120 minutes. That makes a little more sense. Okay. Now, for our cutting, 4 times X plus 3 times Y has to be less than or equal to 120. Okay, so that's one of our inequalities based on our chart here. 4 times how many long sleeves and 3 times how many short sleeves is going to give us a total number of minutes used, and that has to be less than or equal to 120. So that's going to be one of our inequalities. The second one is on the stitching, and so that's going to be 3x plus y has to be less than or equal to 60. And so we have to figure out a way that we can maximize maximize this. Now we also, again, we know these here too, so it's not going to be below 0, and I'll show you why that comes into effect in a little later, and we might actually show that as we're going. So now what we do here is we're going to use Desmos to figure out the rest of this. Okay, and I'm going to bring in my computer and try to get that screen on there. And I'm going to type in my inequalities. So 4x plus 3y is less than or equal to 20, 120. There we go. And 3x plus y has to be less than or equal to 60. All right, and you'll notice they're not there. And now we also know that x has to be greater than 0. Greater than or equal to 0. And y has to be greater than or equal to 0. We can't have a negative number, so that's why we're going to do that. All right, we zoom out. Now you'll notice here, this region right here is the darkest region right there. Okay, so it's not a triangle, and I'm sorry if it's a little bit dirty on your screens there, but this area right here, and I'm just going to pick up some points that goes around it. There we go, that one, and this one right there. There we go. Okay, those 4 points make up this area, which is the darkest shaded region, which is our solution region. Any point inside of here is going to make this whole thing work. Okay, but we want to try to figure out ones that are going to maximize and minimize we want to try and figure out maximum profit. So because we're trying to figure out maximum profit, there is one of these points that is definitely not going to work, and that's our 0, 0. Okay, so we're not going to use that one there. We're going to use these 3 right here. We're going to try those 3 out. So I'm going to put those onto the page. 12, 24, and 20, 0. Okay, and so that's all we need from there. So we're going to bring this back. And there's my 3. Now I'm going to use my target equation to try to figure out which one of these is our optimal solution, or which one's going to maximize our profit. And we just need to find, there we go. Okay, so our profit equals 1.1 times 0 plus 0.6 times 40. This is going to give us a profit of 1.1 times 0, which didn't really need to do. This is going to give us a profit of $24. Next one, profit is 1.1 times 12 plus 0.6 times 24 is going to give us a profit of 1.1 times 12 plus 0.6 times 24, 27.60. And finally, this last one is going to be 1.1 times 20 plus 0.6 times 0. And our profit is 1.1 times 20 is $22. Now you might be able to kind of already figure out, based on those numbers that we're seeing, just going to adjust that page again a little bit, which one's going to maximize our profit. Well, it's the biggest one. That shouldn't be a huge surprise, but this is our max. So manufacturing or making 12 long sleeve shirts and 24 short sleeve shirts will give a maximum profit of $27.60. And that would be our final solution based on what we have come up with and based on what we made using Desmos.